Now this is the next point, that is electronic configuration of the lanthanides. Now when we have taken as a lanthanides, that time the elements starting from the lanthanum having atomic number 57 to 71, having that is lutetium. Now here from lanthanum to lutetium having atomic number 57 to 71, all the elements they have been taken for the electronic configurations. First of all, we are going to see the atomic number started from 57 to 71 as concerned to that is the electronic configurations. That is lanthanum, cerium, praseodymium, neodymium, promethium, sambrium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, lutetium. All these are the 15 elements along with the lanthanum. Before lanthanum, that is when we have taken as onward to lanthanum, that is 58 to 71 means cerium to lutetium. All these elements have been taken. These are called as the lanthanide series. All these 14 elements, they can be shows similar properties along with the lanthanum elements. Hence these are called as the lanthanide series. Now when we have taken as a totally atomic number 57, that time how the electronic configuration can be taken? When you have taken 57, that time generally what happens here for the electronic configurations, what happens totally when we have taken as a 57 means totally 54 electrons should becomes as concerned to xenon. That is xenon will be taken which having that is 54 atomic numbers. Now this electronic configuration depends upon the Apuvaz principle, Hund's rule and Pauli's exclusion principles. Now here atomic orbitals, they can be arranged into the increasing order of energies. When we have taken 1 years, again 2 years 2p, 3 years 3p, again 3d can be taken, 4 years 4p, 4d, 4f we have taken, again 5 years 5p, 5d, again 5f can be taken, 6 years 6p, 6d can be taken, again 6f can be taken. Here that is 7 years 7p, 7d, again 7f can be taken. In this way, how many number of electrons are present, they will be taken as concerned to the increasing order of energies. Now this is called as the Apuvaz principle. Apuvaz principle can be tells that atomic orbitals are arranged into the increasing order of energies, and therefore here 1 is possesses less energy as compared to 2 years, and this filling can be takes place as concerned to the arrows. Now here now totally when we have taken as concerned to the electronic configurations, here the way as concerned to filling of the electrons. Now when we have taken as a 54 electrons or 57 electrons, here 2 electrons can be taken. 57 means 2 electrons, again here 2 electrons, this will be taken below 6 electrons, again 2 electrons, here 6 electrons, 2 electrons, again 10 electrons, 6 electrons, 2 electrons, again here this will be used as a 10 electrons, 6 electrons, again 2 electrons. You should count the electrons, 2 to 4, again 10, 12, 18, 20, 30, 36, 38, 48, again this will be taken as concerned to 54. Now here 54, this idea can be taken as concerned to here, and this will be 56. Here 56 can be taken. Now when we have taken 56 as concerned to 6 years 2 will becomes, and remaining 1 electron can be enters as concerned to the here 4f orbital will becomes. But in case of lanthanum, what happens here? When we have taken that is the filling of electrons, the orbital which possesses less energy, that time the electrons can be enters into the less energy orbitals before the higher energy. When we have taken as a 5d and 4f as concerned to lanthanum, that time it is found that 4f orbital possesses higher energy as compared to 5d. Hence here electron not enters. In case of the f orbital, it goes into the 5d orbitals, and therefore for the lanthanum the electronic configuration can be taken as here 4f0. This will be 4f0. This will be 5d1. Again this will be 6s2. This is the electronic configuration of the lanthanum, which we have seen here. That is, we can say 4f0, 5d1, 6s2. Now remaining, that is again what happens here, when we comes as concerned to the cerium, after the lanthanum what happens in case of the cerium, that time here having atomic number 58, that time it is found that the electron can be enters in case of the f orbitals, because for the onward to cerium to lutetium, the 4f orbital possesses less energy as compared to 5d orbitals, because here we have taken as a f block elements. Last electron can be enters into the f block elements, and therefore f orbitals, and therefore from cerium to lutetium all the electrons can be enters in case of 4f instead of 5d. Means here electron can be continuously added here, and this 5d1 6s2 it is a common. This will be common for all, that is you can say elements. Common, that is you can say 5d1 6s2 is a common. Only electrons are increased from the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 electrons should be enters as concerned to continuously. It is called as the pre-penultimate way. The electrons can be added in case of, that is you can say f orbitals, 4f orbitals, which is called as the ideal electronic configuration. Continuous electron is added in case of the 4f orbitals, which is called as the pre-penultimate way. That is continuous, it will be added. Now what happens in case of observed electronic configurations? In case of observed electronic configuration, there is some difference. How the difference can be taken? For first, that is you can say lanthanum, similar electronic configuration can be taken. But what happens in case of the cerium? Here d orbital becomes vacant. This d orbital electron enters into the f orbitals, and therefore what happens here? This becomes 4f, 2, 3, 4, 5, 6, 7. Once that is this 7 becomes, again extra electron can be goes into the 5d orbitals. The jumping, the electronic configuration for gadolinium, this will be the stability can be mentioned as completely half filled stability. And when we have taken as 0 electrons in case of 4f orbitals, it is called as the empty orbitals. When 7 electrons, it is called as the half filled stability. When 14 electrons, it is called as the completely filled stabilities. And therefore generally what happens here, completely filled stability can be taken in case of the 14 electrons, 7 electrons are filled, and 0 electrons will be taken as a empty orbitals. Therefore this idea can be explained in case of gadolinium, generally 7 electrons, 5d1, 6s2. Again onward to here, after 7 electrons, 9 electron will becomes 10, 11, 12, 13, 14. After filling up, that is here, that is for f orbital, electron extra goes into the d orbitals. Now this idea can be explained in case of the observed electronic configurations. Observed electronic configuration can be studied with the spectra of the complexes. When we have taken as the cerium complexes, lanthanum complexes, the spectral properties can be studied, and from the spectral properties observed electronic configuration can be obtained. In case of ideal electronic configuration, there is no change from 4f, 0, 1, 2, 3, continuously it will go to 14 electrons, and when the filling of f orbitals continuously, it is called as the pre-penultimate way. Electron can be enters in case of, that is you can say 4f orbitals, and therefore general electronic configuration for the lanthanum, it can be taken as concerned to, you can say here that generally what happens here, xenon can be taken as a common, Xc is a common, and after this you can say xenon Xc can be taken as concerned to common. Again 4f 0 to 14 electron can be taken. Again you should take 5d1 6s2. It is a general electronic configurations as concerned to lanthanide series. General means for lanthanum 0 onward to 1 to 14 electron will be comes, and this will be common. It is called as the ideal electronic configuration can be taken. This is general electronic configuration for the lanthanide series. This idea can be taken in case of the electronic configurations.